Okay. Hi. So first I wanted to say I do realize that I'm giving you a lot of videos today, and that may be eating up some of your time. So I'm going to try and figure out a way to make this more efficient. Speaking of efficiency, tomorrow we're going to talk about efficiency. Yeah. And so I wanted to go over this 131A. We already talked about your reading and what you should have got there. There's a link here for that. And now I want to talk about question 33, which is over here. Here we are. So it's about mechanical advantage and a multi-gear bicycle. So I brought out a multi-gear bicycle. There it is. This is the bike that took me from Vancouver to Tijuana one year when I was a lot younger. Woo. And more in shape. Okay, so it says we want to think about some things. So first of all, let's see mechanical advantage. So we're thinking about the relationship between the forces that we're putting in and the forces that are coming out. And ideal mechanical advantage, we're thinking about um, the ratio between the two displacements. Right, so how far we're displacing, say, the front gear compared to the rear gear. And on a multi-gear bicycle, you have lots of options. And if you've ridden a bicycle with gears before, you know that we've got all this stuff going on. So let's go to the front. So on the front, for mine, I've got 3 different gears, all with different numbers of teeth. And on the rear, I've got, I think, 9. You see that? Fun. So all these different gear options. So you may have some idea for how this works, but why? Why do you get the advantage? That's what this question is all about. So the first question says, to start out, you must accelerate the bicycle. So you want to have the bicycle exert the greatest possible force. So if you want the biggest force, if you think of a lever, right, like a bottle opener or the crowbars we've talked about, you move your hand a lot to get the output to move just a little. It's a force multiplier, right? You have a gentle force that you apply over a large displacement to get a large force over a small displacement. That's actually not how a bike works. In general, when you're biking, you're on one of these larger gears in the front and then a smaller gear in the rear. And that's because a bike isn't a force multiplier. The other part of the equation for mechanical advantage is displacement. A bike is a displacement multiplier. You move your feet a little bit as they go around the pedals, and the bike moves really far because this is huge compared to this. Right? The radius of the pedals, the movement your feet make, is really small compared to this. So that's why bicycles are the most efficient transportation machines in the world. You don't have to do much to go really far. So if you wanted to exert a large force, think about what you would choose, a small gear or a large gear. I want you to pause and think about it. All right, you can pause on this image and think about it. What would you do? Okay, if you want a big force, you want the mechanical advantage as close to 1 as possible. If I choose this big gear in the front and this small gear in the back, if you've done this before, this is what you would do if you were going really fast. On my bike, about 50 miles an hour. Sorry, not 50, about 35 miles an hour. So that would not give me a lot of force. So if you think about it, what's going to be closest to 1? Well, this small gear and this big gear back here are about as close to 1 as I can. As I get to traveling speed, say 10, 15, 20 miles an hour, and I want to rotate the pedals as few times as possible, am I going to choose a small gear or a large gear? Again, pause, think about it. Okay, come back. If I want to do as few rotations as possible, that means I want every time this goes around once, this to go around as many times as possible. So this smallest gear back here only has about 9 teeth on it. The big one has about 40. This would go around 5 times more than this one. And I think of the ratio between 9 and 40. It's about 4.5 times. Last question. You can choose the size of the front gear. If you want more force, would you use a large or small gear? Pause again. The answer is small gear. It gets you the mechanical advantage closest to 1. All these other ones would be a very small mechanical advantage. Okay.